Let's balance the classic permanganate iron 2 redox reaction using the oxidation number method. And we're going to be doing this in acid, which means we will be using water and hydrogen ions to complete the reaction. The first step is we need to put oxidation numbers over each species that's changing oxidation states. That's a +7 for the manganese and permanganate, that's a +2 for the iron, a +2 for the manganese, and a +3 for the iron. Those last three are all monatomic ions, meaning the oxidation state matches the charge. Step 2, we're going to join each species to its counterpart with an arrow. So now we have both half reactions shown on the same line. Number 3, let's make sure there's the same number on each side of that arrow of species that are not oxygen or hydrogen. And we're already good on that. Next step, take the difference in the two numbers and write that as the number of electrons. So permanganate going to manganese ion, that's a difference of 5 electrons, and you need to gain them to drop from +7 down to +2. Iron is actually losing 1 electron to go from +2 up to +3. One thing you'll note is this is a gain of electrons for the permanganate, which means it's the reduction, and for the iron, it is the loss of electrons, which means it's an oxidation. You can also go ahead and label which ones are the oxidizing agent and the reducing agent. Notice the permanganate's the oxidizing agent, and iron 2's the reducing agent. We're pretty much all done, except that we need to scale these each so that the number of electrons match. So what we're going to do is make that 1 electron jump up to 5 by doing it 5 times. I'm going to put a 5 in front of both irons, and now I've got to check that 5 electrons for the reduction, 5 electrons for the oxidation. This is a match, which means everything's set up perfect. Everything's balanced except for waters and hydrogen ions. So now we're going to balance oxygens with waters. There's 4 oxygens on the left in that permanganate, so we're going to add 4 waters on the right. That balances the oxygens. There also happens to now be 8 hydrogens on the right, so we're going to balance those with hydrogen ions by putting those on the left side. We now have pretty much the entire thing balanced. So all that's left is doing a final check. I'm going to clear away all the clutter, and I'm going to check this out and go, yes, everything checks out. There's the same number of atoms on each side, plus I'm doing a charge check. And on the left side, I've got 17 positive, and on the right, I've got a total of positive 17 there. So everything checks out, so I'm feeling pretty good. This is the right answer. I'm going to give myself a check mark. And that is how you use the oxidation number method to balance a redox equation. Thanks for listening. I hope it helps you balance some other equations as well. Have a great day.